Fundamental primitives, points, lines, and polygon. Fundamental primitives are basic geometric shapes used in computer graphics to construct more complex image. Dito sa fundamental primitives, ang pag-aaralan natin dito is yung mga shape na gagamitin natin sa object natin sa laro na pwede nating gawing 3D or 2D. Example ng primitive shapes is cube, cylinder, sphere, cone, pyramid, and torus. Ang commonly na ginagamit sa 2D primitives is line, points, and polygons. Points. Points are the simplest geometric primitive representing a single position in space. They have no size or shape and are often used as building blocks for complex objects. Itong points, ito yung mag-define ng location o kaya yung position ng ating object na gagawin. Next is lines. Lines are defined by 2 points and represent a straight path between them. They can be used to create shapes such as polygons or to define boundaries and outlines. Itong lines naman, ito yung magiging guide natin sa paggawa ng shape. Diba sa paggawa ng shape, ginagamit natin yung X and Y sa 2D, tapos X, Y, and Z naman sa 3D para maging guide natin sa paggawa ng object natin para maging tama yung sukat, tama yung position ng object. Kaya itong line, ito yung magiging tool natin para makagawa ng 3D or 2D na object. Lastly is the polygons. Polygons are closed shapes formed by connecting multiple points with straight line segments. They can have any number of sides, but commonly include triangles, quadrilateral like rectangles and squares, and higher order polygons like pentagons and hexagons. Dito sa polygons, ito naman yung magiging guide natin sa paggawa ng mga complex object na para maging mas realistic at mas maging mapolish yung object na gagawin. Next is building complex object with meshes. Meshes are used extensively in 3D modeling, animation, and rendering applications, providing a versatile and efficient way to represent complex geometry in digital environment. Sa paggawa ng mga complex object, may ginagamit tayong mga software application na katulad ng Blender. In building complex objects with meshes involves creating or importing the individual components such as vertices, edges, and faces, and then assembling them to form the desired shape. This is the process of creating a complex object. First is modeling. Start by creating or importing basic shapes like cubes, spheres, or cylinders. This shape can serve as building blocks for more complex objects. Second is editing. Use editing tools to modify the shape, size, and arrangement of the basic components. This can involve scaling, rotating, or translating individual vertices or groups of vertices to achieve the desired geometry. Third is combining. Combine multiple shapes together to create more complex forms. This can be done by merging vertices, connecting edges, or joining faces to create unified mesh. Next is detailing. Add detail to the object by subdividing faces, extruding edges, or sculpting the surface. This can include adding features like texture mapping, creases, or bevels to enhance the realism of the object. Next is refinement. Refine the object by adjusting the topology, the arrangement of vertices, edges, and faces to improve the overall appearance and performance. This may involve optimizing the mesh for efficient rendering or ensuring that it deforms properly during animation. Texturing and materials. Apply texture and materials to the object to give it color, surface, properties, and visual effects. This can involve UV mapping, assigning shaders, or painting directly onto the surface of the mesh. And the last step is finalization. Once the object is complete, perform any final adjustments and optimizations before exporting and integrating into the larger scene or project. By following these steps, complex object can be built using meshes, allowing for detailed and realistic 3D models in various applications such as video games, animations, virtual reality, and architectural visualization. Introduction to parametric surfaces. Parametric surfaces are a way to describe surfaces using parameters. Instead of defining a surface directly in terms of x and y and z coordinates, parametric surface use two parameters, typically denoted as u and v, to define points on the surface. The x-coordinate is determined by u, the y-coordinate is determined by v, and the z-coordinate is determined by the combination of both u and v. By varying the values of u and v within a certain ranges, you can trace out different points on the surface, allowing you to create wide variety of shapes. Parametric equations allow for a wide variety of surfaces to be described, including complex shapes that may be difficult to represent with traditional equations or polygonal meshes. It can be designed to be smooth and continuous by choosing appropriate functions for parameters u and v. This makes them suitable to modeling natural or organic shapes. Example, in animation, parametric surfaces are often used in computer animation because they naturally lend themselves to interpolation and deformation. By changing the parameters over time, you can animate the surface to morph into different shapes. This parametric surface is a powerful mathematical framework for describing and manipulating surfaces in 3D space, offering versatility and flexibility for modeling complex shapes and forms.